You ready? You can turn on the microphone. All right, guys, next up is Ingvar. He has about 5 years of experience as a web developer. He works at Universal Mind, and he'll talk about Serious.js.
Thank you. Actually, when I came to JavaScript about 5 years ago, you know what the trend was? Does anybody remember the times? Actually, it was HTML. Yeah, you're laughing, but it looks at that time like real web magic. Because, wow, we can change colors in runtime. Wow, we can show menu on hover. And it was really cool. We could even do Ajax. We got ActiveX Object and some other implementation in other browsers. We could send requests to the server, get content, and show tooltip dynamically, and it was really awesome. So 5 years went. And at that time, how web model changed. Firstly, we had just web browsers that took web page from the server and show us. Then when Ajax was introduced, we could do JavaScript call for data and get the tooltip to be shown, right? Actually, you don't see the entire picture here. But JavaScript is a really old language. And we got a really long history of development, of optimizing, actually appearing of new engines like V8 that even assembles JavaScript into directly machine code that runs really fast, just like native applications. What changed? We can now separate everything into models, controllers, view models. We do everything in a proper way. And what changed for user? We show the same tooltip with Ajax request, just doing it in a more proper way. And you know, during all those years of development, optimization, and so on, the question is, seriously? Is it all that you can do after all those years? And whenever it comes to any real task, you need to do Ajax request to the server because JavaScript is not enough good for you for doing like real stuff. And you rely on C++, C#, Java, and another like native languages because you just don't want, you hate JavaScript, you don't want to implement it in browser. Why? Why do you think that it's not enough good for a really hard task? I decided to like create demo that breaks this opinion. And just tell me, who of you looks video streams, views in internet? Okay. What are you using for that? Any opinions? It's a real question. How are you watching it? Okay, and in browser, what are you using? How is it shown? Yeah, Flash. You have Flash, you have Silverlight, but you just don't view it. You now have video element, you have all the power of JavaScript to show videos, but you don't view streams just because there is no support for that. Actually, only native support is in iOS for HTTP live streaming. It's Apple's format. And all the other browsers should have to use some native plugins. And what is HTTP live streaming actually? I just I just go through this quickly, just for you to know. So it's basically a list of chunks that are sent from the server to the client, and the client just processes them and shows like a real stream by requesting appropriate size chunks that it can handle and show out to user. Every impg.js file consists of packets, 188 bytes of size. Then they have more complicated structure inside with different like information data, actually raw data for video stream and so on. And elementary stream consists of nel stream that consists of nel units separated by special cons, and so on, so on, so on. You get deeply in that. you get H.264 like frames, and actually you can convert everything to MPEG-4 that is playable in any modern browsers. But video conversion is really hard task that we used to rely for tools like FFmpeg and other native tools. And when telling that it can be possible to convert it in real time, real video stream right in browser, nobody believes. So I decided to break it, and we can do it, I believe. Actually, I described just its structure of MPEG-TS during to all those specifications that you saw. We parse it, we get all the data converted, parsed, and we can show any payload, like program association table from MPEG-TS stream. We can view program mapping table, and so on. And we can actually get raw data from all these packets, combine it to one stream, and convert to MPEG-4 chunks, and play it one by one in browser. So we will produce just the same logic as is provided by native stream. So what we can do is, I hope it works. I was debugging it for half the night. This is a real video stream that is right now, I can show in console log, that is right now converted in web worker in parallel through it and played to you just like smooth stream. And it's even converted, each chunk is for duration of about 8 seconds, and it's converted, as you can see, in about 3 seconds, 2 seconds, and so on. JavaScript is really fast, and it can work on like real hard tasks just in real time. So we can handle binary data directly in browser. I want to tell actually how we can work on that. In the recent specification of WebGL, we got data views is the special specification for actually manipulating any binary data in a convenient way. But it's new enough, and it, of course, works only in new browsers. And it consists of only minimal API methods that were described by Chronos. And Chronos in a mailing list said that they wouldn't implement anything really complicated there, because it should be done by third-party library wrappers. That's why we use Christopher Shadow, that currently works at Facebook, created JDataView. It's a wrapper that can use any existing sources of binary data just like in one way in the same API that is absolutely compliant with the DataView API, and produces some new methods. So actually in browser we can get binary data by sending XML HTTP request with special shell charge sets that will just store binary string and convert it to array of like bytes and use it. Then browser that implemented Canvas, they implemented also fast Canvas pixel array is byte array, the simple byte array that you could use for manipulating separate pixels. Then when WebGL came, there were needed other types and typed arrays, so they implemented int32 array, float64, and so on, from any type that you might need. And Node.js implemented buffer, and in later specification, DataView was implemented. So this library actually wraps all these engines and approaches into one the same way that you can use for manipulating binary data in any browser, starting from IE6 and ending with latest ones, just using different approaches and different performance. But it will work everywhere. So how API looks like. Simple data view provides you constructor from array buffer. It's basically a binary blob where you give just offset a length that you might want to slice from original data. And in GData view, you can also specify global NDNS. NDNS is byte order, actually, that is used. Network byte in network for network streams is used big endian mostly, and for like Intel processors and so on, little endian is used. It provides getters for integers, floats, so standard specification, setter for all those types. It also provides convenient methods for sequential writing of any of these types, because specification requires that in set methods, as you could see, the first parameter should be always byte offset, and it might be inconvenient to always provide it manually. So data view provides you with methods for consecutive reading and writing operations. It also implements bit fields. It's just the same as C++ bit fields, means integers of any bit length that you can also read, write. It provides also 64-bit integers. Actually, JavaScript doesn't support it due to IEEE 754 limitations, but it can use up to 2 in power of 53 integers without precision loss, and after that we can just have some precision loss, and when we need to read, and it doesn't matter to us. So JDataV provides methods for that too. JDataV also provides a method for reading and writing strings, both like simple binary and Unicode. And by sequences, it just fast slices from original sources. Also, it has some specific extensions for JDataV. So you can do all the tasks just in the streaming mode without need for manually setting byte offset from which you might want to read or write specific types. So you can just consecutively read for different data. I'll show you an example. It's like in simple classic style, like data view supports, and in JData view you can just create JData view from some file, read consecutively in 32 and float 32, skip something, read strings, and so on, and that's it. You just get data from any source. But of course, JData view is more powerful than data view, but it's still inconvenient for manipulating on really big and complicated structures. I would blow my mind if I would do all the video converting and using just these methods, because I'm just not sure if I would finish it until today. So what was created for that is JBINARY. It's a high-level I/O library for binary data. What is typical scenario? You can create your custom types relying on standard ones or just absolutely manual, describe typeset, and just load data with this typeset. This constructor. You just provide data. Data is a JDataView instance or any compliant like array, canvas pixel array, and so on. And provide typeset, just a hash set of types that you might want to use there. You have a read and write methods from type from given offset, and ability to cast it with different typeset. You can also move position just like in JDataView for streaming. And how it looks like. You just create JBINARY instance with typeset. Here I provide only one type, all. And it's simple JavaScript object where I put that marker is uint16 and version is int32. And just write binary read all. And binary itself parses all those types and provides you with ready-to-use object. So it's simple enough. Types can be described just like strings. They can contain some special arguments, and they are wrapped in the array syntax, where first is the type name and then are following arguments. You can provide just structure object, which will be parsed from the data, and each key will be used as key in the resulting object and value as type for it that should be read. And you can just provide number, it will be shorthand for bit field of some length. JBINARY provides convenient methods for loading saved data because mostly you don't have it ready, otherwise you wouldn't need to manipulate it at all. And the JBINARY load data method for that that can consume any URLs, file API sources, data URIs, like from Canvas or whatever. In Node.js, on Node.js side, it can be a local file path or even any readable stream, like TCP1 or something. Also, there is a JBINARY load method, just convenient wrapper, where you can provide source types and it will retain binary instance immediately, and to URI that will convert all your binary data that you generated or converted and so on to data URI or blob URI that you might use in video, audio, image DOM elements, and so on, anywhere where you use. Every object creates some context, it's just internal method. I don't think I should stop on that. So standard types are integers, 8, 16, 32, 40, 64 bit. Floats, like standard float and double types. Strings, like chars, simple strings, or null terminated like C++ like strings. Please note the reference symbol in the start of length. It allows to use not just simple numbers, but also functions or another field names in the same object that this length should be taken from. And it provides bit field and blobs for, I think it's clear. Also, there are some control statements, like you might use some flags if a file format needs it, if not, some conditions, and providing types that should be used if condition matches or not. And the references is what I was talking about. It's ability to use not direct values, but also getter functions or string property names. Also, you can create custom types just by providing JBINARY type from your config and providing read-write methods for it. You can provide params. It's an array of names that will be deserialized from that array descriptor. And you might use custom set params function for deserializing all those arguments, or resolving types for internal caching of all the types, so they will not be retrieved like when you're reading arrays or something, they will not be retrieved on each iteration. Just internal methods. So how it looks like. For example, I want to create dynamic array type that consists of length of its hidden field of int16 type, and then array of actually items. So I just create JBINARY type, provide that first params should be resolved as item type. In resolve function, I actually resolve this item type for faster caching. Provide read functions that just reads length and then reads actually array of that length. And in write method, I just write the values length as first data and then provide actually array. And that's all. I can define byte array that depends on this dynamic array. It's array of unit 8, and it will be read. So in this example, byte array has length of 3, as you can see. So this value will be used like length for a resulting array, and so byte array will read only those 3 values that you might see there. But for such thing, you might want not to create completely new types, but use type wrappers templates. They are pretty similar to simple types, but you can rely on another base type that you want to wrap and just override the read-write methods. You get base read, base write methods, and that example transforms to this one. So I provide base type that is just an object of some length and values. It will be read automatically by base read, and to use it, only values will be returned. In the write method, I just create this length field. always transparent for user, and just write it down. How can it be used? Just including JData widget and JBinary scripts in browser. Also, it's possible to install via component.js using a Node.js model or load it in AMD style. I want to show some demos of how easy it's to use and what it can be intended for. I just created from scratch, so you be sure that I didn't prepare it. I just include require.js. Also, I include onConfig. Wait. And this config is our only path to GitHub repos with this script. And for example, I provide input of file type. And define shorthand for. And require actually JBinary. And JBinary repo, it's a repository of some ready-to-use typesets for your real projects. There are too few in that repo for now, but I hope it will grow, probably with your help. And here I put listener for actually file changing. Small screen enough. And load JBinary from the first item of this file. File API provides us with a files array in each input file element, but we don't have multiple selections, so I just take the first one and call JBinary load on it. And let's just output that, I don't know, to console. So now you can just choose kind of file, for example, gzip. And as you can see, I hope you can, yeah, I can. JBinary instance was created. Actually, this instance. And then I can read data from it, actually. I can call read all for reading entire file as JBinary all structures that was defined in its typeset. And so entire file will be just parsed and presented as single object. Here it is. You see that gzip was completely parsed. And please notice that I didn't tell JBinaries that it is gzip. It just found it by MIME type and association and file extension association, and found that it should use gzip typeset for parsing this file. So if I would choose, for example, I don't know, icon file, I would get completely another result. There's just an array of icons in this file, and it's also parsed because of file association directly inside the library. What cool we can do is this. For example, let's rely on gzip demo. I can use it with require.js plugin syntax, just loading, for example, gzip and tar structures. So data in for gzip was looked like this, and here we get content function. Content is just lazy getter for actually decompressed content of gzip archive, And as you might know, gzip contains only one file, so this content will be, for tar gzip, will be actually tar archive. So we can just extract it as separate file by using data content. And I say that as I want to cast it to tar archive. What I do next, I, for example, add the link. A reference to it. Set a download attribute. It's a relatively new attribute that used in Chrome and Firefox, and actually Opera 15 for setting name of files that should be downloaded from this link if it's generated dynamically. So in download, I just set data name, name of the actually file that was compressed with gzip, and in its text content actually too, so we could see this link. And its href I set to tar to URI. Okay. Probably. Oh, yeah. I love this Wi-Fi. And, okay, it worked. And now I choose our tar gzip archive. Here I got linked to the sample tar. I can download it just like a regular file on the desktop, for example. Oh. And to open it, we can see that it was completely decompressed. It's just tar archive, not compressed with gzip no more. We can go in further. We can now read all from tar archive and provide it to user. So we got just an array of all the files in this archive with their names, modification types, modes, and so on, and content binary that actually can be used for extracting this file now from tar archive. I can even like change this link to download the first file in this archive, for example. I set tar data to this tar read all. And take the first file. Zero. Dot name. I hope the first file isn't folder. No, it's not, but it's strange. Git ignore readme. Okay, I'll download readme. The sad one. And here I set just tar data 3 content binary to URI. Ta-da. I can download this README. And use it. It was completely extracted from both gzip and tar archives directly in your browser just in 1 second, even less. We can actually even, if I have enough time, we can actually set our own typeset. What practical example can we have? Let's say we are building audio player, right? And you want to play MP3 files, but from MP3 you have no ability to extract actually song name, like track and so on. You need a database on the server and providing a JAX request to it and getting the data back. But why are we doing all this stuff? Why do we need connection at all if we can read all this data directly from ID3 of MP3 file? So what we are doing? Just creating audio element. I removed it. Stupid. And as for now, I just set audio source to this file. No, actually, I have to read JBINARY firstly, because you can even play local audio files without generating dynamic URL. So I tell JBINARY load. I don't need actually gzip and tar no more. JBINARY loads these files 0 as mp3 object and getting callback. And defining mp3 examples are example. I provide special JBINARY all options that directs JBINARY to type that represents entire mp3 file. It will be, for example, in our case, I'll just parse id3 and set id3 structure. For now, just to empty one. So I call JBINARY load, get binary. I can set it to URI and set it to audio. Controls. Okay, Opera doesn't support mp3 for good. I do it there. So it's loaded. Actually, it's not done. We still need to get some name and check if it's really that what we thought about. We just go to Wikipedia, looking for id3. Yeah, Wikipedia is our friend. Okay. And I hope this will be enough. I'll use the id3 version 1 because we don't need really any extra information. Title and so on will be enough for us. So what we see there is that id3 is used from 128 last bytes of the file. So firstly, I'll just put special direction for JBINARY that should skip. I'll maximize it later. That should skip just everything except last 108 bytes. Then we have title, artist, album, and so on, like string SETI. Let's call it meta string and define it as string of length SETI. And now define actually fields. Oh, sorry. Meta string is type, so I should put before id3. And now using it in our fields. Artist is meta name. Album is met name. I skip title. Title is also meta name. UR is just string of length 4. Comment is something of length of 30. So I just string, actually I put string 0 because it's not always 30 bytes length. it's node terminated string. So here it's here it's a meta name actually too. And then we have genre. Genre is indexing the list of genres, so it's enumeration type. Enumerations are used just like in C++ or any other language. It's based on 1 byte here, so I just provide you int8 number, and then providing a list of genres that it should be decoded with. Where we can get it? That. Yeah, so that. So here we have site with list of all these genres. What we do is we are doing magic. Yeah. Just change it with regex replace and putting it all into the array. Oh, it's 5x. Right there. 148. I would blow my mind if I would type it down manually. So, yeah. And run. I hope it works for the first time. So, oh, sorry, I didn't show it anywhere. So I should just do binary read all and put it, for example, I'll put the pre. Put in JSON, and here I'll just put it set output text JSON string gify all the data that we read with null and with nice indentation. And where it is. Now type meta name, which is string. Why is it? Oh, meta string. Sorry. So meta name. I skipped the tag. Yeah, there was tag on Wikipedia. Tag is a constant that actually shows that it's really ID3 tag. So it's constant of string of length of 3, and it should be equal to tag. And yes, that's strict for us. We should throw exception if it doesn't match. Here we get everything. And it's also done in your browser without any request. I close my presentation, so any questions? Sorry?
Hi, that's really cool. Do you have the code for this video stuff you showed in the beginning somewhere?
Exactly for video?
Yeah, just this example you showed in the beginning. I was wondering. Look at
it's
the
not
code.
in public yet. I can show just so you could be sure that it's not done in C++.
No, I'm sure it's done. Like, I trust you, but I was wondering if it's somewhere on like GitHub.
No, it's not in public yet because I want just to fix some things and add HTTP dynamic stream and Microsoft Smooth Streaming, so I could get all the streams available to end users, so it could be used like unobtrusive JavaScript that would be just like included a script on the page, and on non-iOS devices it will play everything using conversion. It will be like separate.
Looking forward to it.
Okay. Here are MP-GTS typesets if you want to see, and MP4 actually. Yeah. Any more questions? There was one, I remember. No? Okay.
All right, thank you. So I'll let you off for a coffee break. We'll continue then at 3 o'clock.